Other is phenomenals, and we are searching machine. For example, as searching machines like Google, Yahoo, that making the better than other things as human searching, and gives the what we want to reach the perfect goal that we can do it by this phenomena. Both the research things
ಎಲ್ಲೈತೆ
Sorry for the interruption. Sorry for the interruption, participants. Right, thank you. I'll continue. So why the interest in AI? Why the interest in AI? So look at this pictures. the labor, science, appliances, search engines. So let us come to the one by one. Why we are going for interest in AI? Why should I implement in the present world present technology to the various areas? The labor. See, the labors cannot uh, okay. So labor. So why this labor is required? So labor is required for the especially for AI intelligence is very much required. So why this AI is very required? Because human cannot do such a kind of work, the where human specific task. So there we require more number of labors. So then we can do instead of that more number of we can now. So that is a major drawback. We can implement that AI so that AI that machine can reach that particular area so that it can work. So that we can implement it very easily, fast, very accurate. So we can do the perform a particular task. And if I come to the science, the science is very important. Rover. So look at this rover figure. This rover figure. This rover figure. The where the human cannot go there. So such kind of areas that we can implement that particular technology, AI technology. That technology will reach that particular area so that it identifies that the particular parameters in particular area so that there where human cannot approach. That's why we are interested in AI in this particular application. This application we are interested because this is a very specific task where human cannot go that particular areas. For example, Chandrayana 3. So there, that is the rover that collecting all the data through parameters and sending to this receiving station. There, human cannot go there. Hence, we are very interested in made of AI technology. So that very much interested. So that the people very attractive about this kind of applications. Science. If I come to science, for example, this is science and sciences, appliances. Appliances, you can see the washing machine, camera, and other electronic gadgets. So look at these three. So as we see these equipments, as equipments are there, manufacturing peoples, there we are expecting that very accurate work from this machine. So that accurate of expecting the machines with we compulsory we need AI. AI will do the particular task very accurately and fastly than other technology. Then other technology because of that work efficiency we can identify that through this AI technology. That's why we are interested in appliances also, electronic gadgets, washing machine. Not only these kind of appliances, many more appliances are there. That's why we are interested to do the way only through that we can do it very fastly, accurately, and very perfectly. So this kind of engineering applications. There are engineering applications. If I come to the search engines like Google and Yahoo search engines. If I come to the Google Yahoo search engines, so we are first, for example, why this Google and Yahoo they are interested in AI means they are specifically I'm trying to get some information about, for example, machine learning or deep learning. So there we are searching a particular application, particular work. We are going to see through Google means we are searching, go on searching, go on giving. Google will take this information from that side, from human, from our side. Then it will use final information to reach the what we expected. The what I need that will use by this Google because of this search engine. They're using AI because of AI. Because AI can give if you go on giving the deep learning or what is the deep learning, what is this things. But we want deep learning using image processing particularly what is image processing. Suppose I will take in healthcare systems. So there, the Google is giving one by one, one by searching, giving the data and information to the user side. So finally, we human can take that from particular that information from the Google search engines. On giving this, the asking the questions in Google, it knows this search engine is knows yes
what do you want, what is expected from me, that he will give the information through this Google one. This is what which AI we are using, knowledge based system, knowledge representation system we are using in Google Yahoo Yahoo search engine, so that they are giving understanding what user want to do, what user want to need expecting from my side. So go on giving one by one information. Finally, it reaches our what we expected, that we will send to the user sites. That is one of the best the search engines nowadays they are using. So search go our engineers, budding engineers are very much curiosity about making of research and any other particular area. They are giving these kind of means AI is very thanks to AI, because they are giving the correct information. Final what the user needs, that will give by Google things. If I comes to the medical and diagnosis, yes, this is very very important nowadays. This artificial intelligence is playing very important role in medical diagnosis. How it's medical diagnosis role playing artificial intelligence. So we know that in every diseases in medical diagnosis, there are so many diseases are. So nowadays we are seeing and observing in and around our areas, whether it is BP, diabetes, diabetes melonopathy, cancer. So various kind of diseases. How this diagnosis by using, in the olden days we are using CT scan, X-ray, MRI scans. So nowadays AI Google scan, AI Google scan. That is the only coming, that will take the photo of complete human body, whether it is a head or a stomach, wherever the parts of our body, it will take scanning once, only 1 or 2 seconds or minute scanning, that will give us where the actual problem will occur. Whereas if you go to the old convolution methods like CT scan, MRI scan, it will take procedure, convolution procedures, that will give us a backlog in technology. So nowadays, now they are implementing this AI technology in medical diagnosis in many health issues. That is why we are interested in AI field. What else are there other than this AI means? So many, yeah, many things are there. Still, it is not end. Still, it is a sea like lake. Still, we have to go improve our search engines to find new things. What will happen? The AI technology. So what are the areas of AI? Some dependence. We are depending upon the areas. What are the areas are there? Dependent to give this kind of applications, engineering application, medical application, diagnosis applications, and troubleshooting applications, etc. Many more applications. How these applications works, that I want. What are the areas? What are some dependencies? We are going that one. First, I am going to take that one search. Search is one, what we are seeing, what we need. Just example, I showed search engines. It go on giving the data from the search engines, and it is giving to the sequentially executing the steps one by one, one by one, one by one, and send to the logic also taking the information, complex problem solving, and optimizing the data, and send to the other one. Knowledge representation. I'm going to the knowledge representation. The knowledge representation also, it's a human expert, a specific domain. Is a specific domain, a human task. It is a decision rules and mechanisms, and knowledge a specific domain, particular task. You can collect the interference of data in this knowledge representation, doing a whatever you're collecting the information and send to the uh, natural language processing. And that come to the expert systems. If you go to the expert system, this expert systems complete decision making, tax, rules, diagnosis, financials. So many things are done in expert. Things are there in expert systems. This expert system will give a lot more things I can do, make the machines by using this expert system. Planning, planning sequentially, and send to the robotics to the do what else to do, what needs to do the robotics, how it is planning. The planning requires logic, and again it requires search. How to the robotics works in particular area and moves and walks and carrying those things. That all these things are done by robotics. If I come to the machine learning, as we know, yes, AI, machine learning is a subset of AI. It is definitely, it is a subset of AI. It is a subset of AI. This machine learning will handle some sequential data, explore the statistical data to the vision. What vision is a computer vision? For example, I am making image processing. This collects all the data where the image, for example, neural network, for example, brain image or retina image, all the so many millions of image. It collects the data by using a machine learning. Machine learning will do the collection of all statistical data to explore the knowledge systems. This machine learning or any kind of application, this machine learning is a subset of AI and will send to this vision. This vision, what will do? This is a vision. So it will make the computer vision to give the what display we're going to take from the input of the machine learning. At on the same side, search. The vision takes also the input from the search. Search means collection of data, sequentially executes the each data collected from the machine learning, execute step by step, and what we are going to view the, for example, retina, so many millions of data appearing the, and we can see where the exact disease is occurring in the diabetes melanopathy in the exact figure in using of computer vision. For example, next, so many examples are there in vision. Next, NLP, natural language processing. The natural language processing is one of the branch of AI also. It takes the knowledge from the what specific domain humans can do from the knowledge representation, also a logic, also search from the data. Three inputs are taking a natural language processing. This processing, how it works, how it will translate the text message, image message, all these data is taken from the knowledge representation, logic, as well as search. From these three data, we can acquire in the knowledge processing, and it will take a small amount of data where we can do a particular, a small amount of task assigned to the NLP. For example, let me take for last, you can see G20 has done in the government of India in the last 2 days back, where we can see all the president of countries, the different languages has been. See, we can there, we are adopted a AI technology because the each country their own, they're speaking their native language, but it's translated to English so that everybody can understand their what is speaking. That using what AI. That is what we can there implement natural language processing. It is translates the data, communications data, translation, text message converting. All this can done it by is NLP, a natural language processing. That's again nowadays we can where we can go, we can translate. Also, we can use in our mobile phones language translations. So this kind of technology. Next, we come to the expert system. The expert system takes the input from the logic as well as the uh, uh, what called logic things. So what expert system? The expert system is a human basics specific task we can do it. So what it does, what it will do, the expert system is the decision making facts rules, what decision we have to take. For example, robo, we are assigned to do this particular task. That is expert system. Beyond this expert takes all this data acquired to from the logic things and as well as the knowledge representation. Use user interfaces. Expert systems takes the user interface hardware. So it takes from logic as well as knowledge representation. From acquiring these two data to the expert systems and this behaves what we assign that decision making facts, what kind of rules, heuristics that can experts is, and it will observe it, and we assign it a particular robo, whatever it may be a technology in engineering or medical healthcare system, it will going to do a specific task using expert systems. These are all these things, all these what we can 5 plus 4, 9 areas of AI. Some where all this branch of also areas of AI or branches of AI we are all depending upon these things. So not every technology we are going to say robot. It may be a robot, it may be computer vision or healthcare system, financial, troubleshooting, medical diagnosis, engineering, any applications. We have to go any particular blocks. There is a knowledge representation or expert system, any one block or robotics or computer vision or NLP, any one block will work it. so that we can give a particular applications to the user side. A machine can do it, so that a human can see how it works. These are all these things they are making intelligent machines. Not only all the nine the areas are dependents. Some particular some we need 2 areas, 3 areas, or altogether areas. So planning to robotics, machine learning to vision, search to NLP. NLP takes 3 inputs: logics, search, knowledge representation. Vision takes machine learning as well as search. Robotics takes that planning. Expert systems takes that logic as well as knowledge representations. So all we are depending upon these areas where we require and kind of application what we are executing, that depend upon the AI. So let us come to the branches of AI. What are the branches are there? So not only we can particularly say AI has so many branches to work a specific task in all the areas. So what are the first area? Logical A branch. It represents the agent's world goals, current situation of the sentence knowledge. Logic search, as I told you already, that search is always you're using search engines, giving a new things, and finally reach the goals. Language processing, machine translation, summarization, ticket classification, spell check, so many things you can do it by NLP. Computer vision, already I explained that the computer visions identify the understand the objects, what kind of image objects, speech, everything you can the people of image and videos, everything you can do it by one by computer vision data can take it and it will work it by this is one of the branch of AI. Pattern recognition also this comes especially we can go through the image processing, knowledge of the image processing, gain satisfaction information extracted. And knowledge representation is one of the branch. This also a user interface, Excel in giving the data and executing rules, decision making, what are the facts are there, and how it represents a specific work and interference mechanisms, frames, scripts, and capture the knowledge and in a specific domain. Reasoning also, what kind of reasoning we are going to giving the particular task, and that will use also a one of the branch. Learning the what data we have to give to the machine. That learning also will help us to taking the data and working out. Planning, planning to generate achieving some particular goal, the specific task by planning also. Epistemology, this is study of kind of knowledge required for solving complex problems in the world. Not only the simple problems as well as complex problems also we can do it. Anatology is one of the study of things that exist. Any anatology is there that what kind of things we have to make by AI that we can do it. Agents also they are doing games, artificial life, emotions, knowledge management, socialization, communications. These are all the branches of artificial intelligence. So with all this technology, we are making the human intelligent machines. Next, next. So what is artificial intelligence? How it works? We are classified into 4 types: the thought and system that think like humans, system that think like rationally, behavior, how it is behavior, system that act like humans, system that act like rationally. So using, I made a red color, the behavior of system act like a humans. How it act like a human? The system, how it act like a humans? What are the technology we are implemented? What kind of machine you have prepared? We have made a model. How it act like a humans? Whether it is a moving and going, walking, upstaring. So any how it works, behaving. So all these 4 blocks thought, behavior, human, rational, we are going to giving that in the implementing in our machines. Let us study that how systems that act like humans. Very good. The art of how system act like humans means the art of creating the perform the functions. How we have to make creating functions? We are going on knowledge representation is there, expert system is there, and machine learning is there. We are making that systems to act like humans. It creating that how the human acts, the moving of hand, moving of leg, turning of head, everything is act like a humans. And how to study to make computers do things at which the at the moment people are better. The how to make the computers are better, so that the people are thinking that way, and how it acts the humans the same as that of systems acts like that one. That we make it the basic things of artificial intelligence. The system act like humans. If you are entering a room in a one period of some fixed period of time, you want to a terminal. A terminal means terminals, computer terminal. What is that replies? If a computer system at the end of the period, it determines the system human, it deemed to be intelligent. Means after one some fixed period of time, it we are making the programs, and it acts as an humans. We are making the system. You are writing some programs of any language, and we are making that machine a particular model. It acts like a humans. So that is one of the how the system making into humans. System act like a humans. System that act like humans using the particular test. We are deeply simple method of determining the whether system is demonstrated or human intelligence. It asks some questions. The computer or human answering the which question, what how to control that on remote communications, how the computer behave like a intelligently, what kind of question it is asking, and how we are going to behaving. The machine is behaving, the intelligent behavior as the made in the computer programmings to the inner systems. The system act like a humans. The system act like a humans. Viewing the cognitive task. What is cognitive task? How it cognitive task works? Cognitive task is a simulation of human machines. We are making a human simulation. It acts like a human, like intelligence and learning, perceptions, attention, language, memory, processing, problem solving. That is what cognitive. So what are the types where the cognitive means? Simulation of humans. It takes that machine like intelligence. It solves the problems, learning, perceptions, attention, memory, a language, processing, a problem solving. All these things are cognitive tasks. How its memory keeps the memory, how what task you can going to do, attention, perception. A machine takes perception. What are perception? Actions, just like a human intelligence, how it solve the problems. Suppose I assign some work to this robotic, it solve the problem, it bringing the things from place to place. That is what it acts like a human. That's solving a problems. And attention, where to go next after solving completion of this task, where to go, that is attention. So all these things are cognitive tasks. The cognitive task includes what? Natural language processing, its communications for the humans, knowledge representation, store the information effectively, efficiently. Knowledge representation means collection of informations very effectively, efficiently in the systems. Automated reasoning. It takes the retrieve and answer the question using stored informations, and it is automatically the stored information or memory, what I call it as, and problem solving. Machine learning. It explores the statistical data. What kind of data you require to act like a humans? That machine act like what kind of data it sorts the data. It sorts the data. What task assigned in the program, how to do, how to work it. That is what machine learning. Machine learning is a subset of AI. I told you that. That is, it takes the statistical data and works any kind of it. Maybe you can take it as for the speech learning, communications, and text message, whatever the data are collecting, a number of billions of data the kept in this machine learning, it gone giving to that particular machine what we assigned to that particular machines. It will take the one by one and adapt to that and works what we assigned. That is bringing the things from place to place as the machine learning used to the systems or system like act like a humans. The types of artificial intelligence. There are two types we classified, mainly type 1 and type 2. What is type 1 and type 2? The artificial intelligence are there. We have three types four types in type 2 in artificial intelligence, mainly classified. In type 1, artificial intelligence is called as a weak AI, narrow AI or weak AI. It only limited performance. It trained only specific task. It trained only a specific task. Specific tasks. It's called a weak AI. Weak AI. General AI. General means what types of intelligence would require intelligent task, efficiency like humans. That is what the general AI that the human can do. Super AI, strong, it's also strong AI. It machines we are made it surpass human intelligence and perform any task better than human with cognitive properties. I told you the cognitive properties. Cognitive properties are a simulation of human that kept in the machines. It solves the problems like learning. It takes the perception, attention, memory, languages. These are the cognitive properties kept inside the machine. It better than human. It has an outcome of a general AI that's called super AI, a strong AI. It's also called as strong AI. Next one, in type 2, if you come to the type 2, reactive machines. The most basic types of artificial intelligence is that it do not store the memories, but it takes the past experience for actions, past experience of actions, past experience or future actions. It not memory. It will not take memory. This is reactive machines. Only future what you have to do. That machines we are made it. That we will take only that particular specific task. That it works. That future actions. Let's come to the limited theory. This limited theory is it do not store the memories, but past experience, but future action. These machines only focus on current scenarios, react only as per as best actions. Only previous to this, I mean, limited theory, reactive machines. If we compare to those two, the reactive limited theory only the best action we can do compared to the reactive machines. If I come to the theory of mind, still it is not developed that one, but researchers still making the lot of efforts to improvement of developing the theory of mind as exactly even the how it feelings, psychology feelings, all those things, but still not yet. They're doing some research work in the theory of mind, including self-awareness also. This is also still the research is going on in self-awareness as fast developing, but still not at the result, not implemented yet at the market also. Coming to this self-awareness, not available. So the rest of the things types of artificial intelligence we are made the machine, and already we have seen the in our daily life, already implemented in many more industries and all some in technology engineering problems. Next, the second one, as you see, this already explained that system acts like humans. Next, a system that think like humans. How it your system in thinking in human way that we have to understand it. In what way they are thinking that the machine intelligence in think that.
ಈಗ ಈ ಆಕ್ಟಿವಿಟೀಸ್ ನ ಎಲ್ಲರೂ ಮಾಡಿದಾರೆ ಏಳು ಆಕ್ಟಿವಿಟಿ
The humans using a system think that like humans means definitely it should be cognitive science, cognitive modeling. Cognitive modeling means I already told that the properties like that cognitive modeling property, thinking, logically thinking, and memory, decision making, and taking this right decision in a specific task. That I told you that in cognitive modeling, all those properties are implemented to this machine as a system that think like humans. How do you make human things? Using introspection, psychological experiments. Using psychological means the human psychological and introspections. How to make that human think in a fastest way for the specific task. For example, cognitive science. In the cognitive science, and a new effort to make computers think the machine with minds in full literal sense. Machine with minds. How the human thinks what directions after completion of task, and working the how it works, how the human works, same as machine will work. After completion of each task, how will man will work, same as the machine will work. That is what the exciting new effort to the make computers think. The human automation of these activities we associating with the human thinking activities, decision making, problem solving, learning, all these things. Problem solving, learning, planning, decision making, all these things, they're all coming under cognitive modeling. We're kept inside the machines that the think like humans. Very clearly how we are seeing so many robots in the in specific tasks, you can see in the industries, how the humans are working, bringing the specific task, bringing so many things wherever we want, and going in the particular areas where human cannot reach. Those how it human robot will work, because its cognitive properties are kept made that in the things in the machines. How activities such as decision making, problem solving, learning, all those things they kept inside that machines, so that the robot will start work, and for a particular task, and everything is written in the programs, and what timing it should work, how to make a solve the problems, how to learn it, and how to complete the task, that by the think like humans. For example, that cognitive model depressions, for example, is a depression, feelings associated with the depression caused by irrational thoughts, beliefs, failure, inadvocacy. These are all the examples of think like humans. That we can make a machine act like a machines. Artificial intelligence. Now the come to third one, system that think rationally. What is mean by rationally? Thought and rational. How to make thought and rational in machines? As the loss of thought, the rationality. The humans are not always rational. What is rational? Rational is in terms of logic. It is a logic we not express as a human express. It's uncertainty. We can change our mood. Like that, the robot or a machines are changes mood. So how to make it as a logical approach is a feasible, not a feasible solution, but computation time to make such things that system that think like rationally. The computation that make it possible to pursue a reason to that the system can work or to possible the perceptions and think in that way by the machine. For example, you can say this a system that think in rationally means Socrates is a man, all men are mortal, therefore Socrates are mortal. So in that is a way of thinking. The system means Socrates are man, is a man, is a group of is a group. Mortal is their own what do you call it as a group of people. They are making particular religions. So finally, the Socrates are moral. The thinking in that way, what we thinking is Socrates is a moral. We are giving an answer as a human. But how the machines are thinking in that way, Socrates to moral. Socrates is a man. All men are mortal. Therefore, Socrates are immortal. So therefore, Socrates is a man. So that we are preparing, training the machine that thinks that rationally. Rationally means directly we can go to Socrates is a mortal. Thinking in that way. So the machines we are trying to give using all cognitive properties better than humans. So we are going to give in this way of training the machine. Another example, for example, TVs use energy. The energy always generates heat. Therefore, all TVs generate heat. See, this is a logic reason. The machine think in that way. The machine think rationally. TVs use energy. Energy always generates heat. But all TVs generates heat. That is a way of thinking the machines rationally. Next, third one, system that act rationally. Now it is computer thinking. Now how it act rationally? Thinking is one thing. I already clear that one. System that act rationally. The behavior means rationally. Rational agent. the mathematical model that tries to represent the behavior of intelligent like person or animal. We are making a mathematical model to tries to rational agent. What I just give an example in the previous one. TVs uses energy, energy produces heat. Finally, TV generates heat. Like that, thinking randomly, and how to make it a mathematical model in kept in machines. How to train up that one machines. How to behave intelligently like person or animal. It uses a set of rules to determine the best course of action for a given situation. How to act, system act rationally, called rational agent. What is rational behavior? Doing the right thing. You have to do it in a particular timings, so in the right way. What is the right thing? Expected to maximize the goal achievement from the available data. From the available data, how the system or a machine it reaches the goal we expected from the available information which is kept in the programmings. That is what right thing. Giving answer to the questions, acting. What the questions asking to someone, to the machine, and giving that answer. That is what acting. Suppose we are suppose somebody is asking some questions. So machine giving an answer. Suppose what is your name? Yes, my name is Robo 1, Robo 2. Like that, it is an acting, showing in acting. But it is a replicate human thought process and make some decisions in as humans, usually purely logical reasoning. Is a replicate of human thought process. How this act rationally? Logic is there in rational agent, and but doing a particular specific task, human knowledge informations. It covers the entire general different situation problems. It incorrectly reasoned conclusions. It may give the maybe wrong answer. It may make you right answers. Not all rationality. Sometimes if you base it on logically, it gives make correct results. May not be give results. So the machine may not be give. Sometimes may give correct one based on what information we have kept inside the program to that particular machine. That also depend upon carries. That may be in machine learning also there, and maybe deep learning also there. That machine, the system that acts rationally may not give the correct answer to the giver for questions. Act rational agent. So AI rational it has two advantages: the logic plus domain knowledge. Because the logic is there and domain knowledge is what particular task is that we are given that one, that particular domain, whether engineering domain or medical domain or financial domain, that applications that depend upon domain knowledge. We are going to asking the questions whatever the particular task based on that one. That is one of the advantages. The two advantages. Some scientific methodology also. For example, another example I may give a chess player. Determine how it moves the result in the most of the advantage outcome for it. How the in chess the pawns are moving. They think each pawn are moving very planningly. How to move the in opposite partner, how he moves. The robot also, a machine also moves very planningly, rationally, because thinking in twice, three times. Because the domain knowledge, I made a prepare that that machine, a chess player game as an application one. How it works, how the moves the point to one another based on the information available in the particular machines. I mean, so is a knowledge-based representation. Knowledge-based representation, that information available, it moves the coin. So not rationally, not it act rationally, not acting maybe in the correct domain knowledge. Only just player act rationally, correct way of method, the moving the pawns, and particularly the how to move each kind, how we have to explain how to move one by one as opposite person or playing with these machines. That is what thinking rationally, because rationally thinks three times, four times better than that human planning. The goals of AI. The goals of AI, we know that to make computers more useful than letting them make over dangerous or tedious tasks from human. So we see that in the figures. How the human thinking that goes in the he is thinking A first come, next come B, next come C is storing. But in front of that machine in the robo, we are giving B, C, A. First, it is taking C, or it is first taking A. It is specific task, or first it is taking B or A or C. But it is thinking that C should come last. Next of that C, B. After that one, A should come. So this is the a specific task rules, and is thinking and perceive attention and what intelligence you need that machines to what is thinking in that way. ABC could come in as they see in the orders, but we have kept these alphabetical one these things randomly how it picks correctly in what is thinking the machines. That is what cognitive modeling, rationality. The foundation of AI. How this foundation of AI, they are categorized into three areas: computation, logics, probability. How a computations leads to analysis of problems, how we are solving the problems, like what is in the previous one, in complexity theory, and degree of belief in probability, how to handle all those things. In these three areas, computations, mathematical problem solving problems, or simple problems, or logic problem, complex problems, logically thinking what to do, solving the problems, and probability, how to make probable solution to the problems, and language is processing, problem solving, and all those things. These three main areas to give the complete foundation of artificial intelligence. If you come to psychology, how do the human thinks and act, the reasoning, acting, a reasonable model for AI, strengthening, efficient computers, and power of computer make computation large difficult problems, and has contributed to own work to computer science, including time sharing, data types, and language like oops, etc. These are all the required for making the machines. How the human thinks to better models than the better than humans to get applications in various areas to follow the three foundations like that computations, logic, and probability, with combining of all the psychology effects to on the machines, preparing that AI programs that we can get ultimate result, best result, accurate results, fast actions as compared to human thing, better than humans. So that is what psychology thinks. So main topics in artificial intelligence we are classified to do the things the machines are things better than human, or search includes game playing, presenting the knowledge and reasoning, planning, learning, natural language processing, expert systems, interacting with the environment, whether it is in vision, speech recognition, robotics. So as we see that what is search, what is representation knowledge, what is reasoning with that, what is planning, how to make a planning, the system making planning, learning, natural language processing, expert systems, and interacting with the environments. So let us study the one by one. Search. Search is fundamentally is one of the AI technique. How to make a search? I already told you the search engine. For example, the blind, we move through the space without worrying about what is coming next, but recognize the answer is correct. Suppose in Google, I want machine learning. So you go on giving the machine learning program topics, go on giving one by one, but still I am not getting the what right information to me, but is not approaching. Again, I am giving that one in the search engines and inform that we guess what is ahead. The user particular information decide where to look next. We want search the first answer that satisfies our goal. We may keep on searching until we find the best answer. We are gone keeping searching what I need, whether it's a research, whether it's a medical field, whether it's a financial field, whether it is a industrial field, until we find the best answer from the search engine. That is what we require. That is given by search, whether it's a Yahoo or a Google one. For example, games, Sudoku, crossword, all these gives the best answers. We are going the giving the search engines. Go on giving that one. We can give playing the games, best games. Go on to, playing the games. Finally, we reach our goal. Sudoku, crossword, so many things are there. We can do it by search engines. Next, knowledge representation and reasoning. The most important in AI is that care and reasoning. So if we are going to act rationally in our environment, uh, we must have some way of describing that environment, the decision representations. So how knowledge representation is there, how to work that one in knowledge representation means in specific domains, logic level, decision mechanisms, frames, scripts, knowledge specific domains. First one, let us describe that how to, what we know about the world, how to, suppose we have to make a machine, intelligent machine means what specific we have to do, particular applications that we call that describing the world, new world. How to describe it consciously, what are the data and information to send to make a program to that particular task. How to describe that one, we can get hold of right piece of knowledge when we need it. When we need it, how to for the particular task, how to work out that one. So that we are called in a knowledge representation. How do we generate a new piece of knowledge? A piece of set of training sets of programs, how to make that as a knowledge to the machines. How to deal with the uncertain knowledge, because the certainty is not there, uncertain some work is there coming in specific domains. How to make, how to train the machines to in uncertain knowledge, that is also comes under the reasoning and knowledge representations. For example, a better example, let me say that one, diagnosing medical conditions. Diagnosing a medical condition or having a dialogue in a natural language. Medical condition. So medical condition, for example, retinopathy. Because of diabetes mellitus, a nerve damage is occurring in our retina. So how to diagnose? That is what knowledge representations. Collecting of all data, number of billions of data. What is the medical condition is there? How to take a decision in the right place? How to make a knowledge? How to take a uncertainty? How many damages are there in retina? Like that, we are all studying the incomplete retina of eyes of given things. Dialogue in natural language. What is the dialogue in natural language? See, because so various local language, we are making the equivalent English language. So that how to make it given a particular task, specific task. That is what knowledge representation also coming under this reasoning and care knowledge representations. This is one of the best example for care knowledge representation and the best reasoning. What is knowledge and declarative procedures? Knowledge, declarative knowledge is a fact type questions. What is capital of India? Questions in declarative knowledge. Procedural knowledge is that how to make it. How to make it. The procedural knowledge can be embedded in declarative knowledge. So how and what? They are doing. How and what? They are making that knowledge to this knowledge representation systems. Next, you come to the planning. So set of goals is there. We have specific tasks we can compare to our systems. Now, how to execute them? How to execute them? How to execute them? The actions. Planning refers to determining the sequence of actions that don't achieve particular objective to the performance. Most of the work independent of the most other parts. So necessary actions, planning and executions are very important. And what will happen? And next, how to make the machines to the plan to go next work, and what not to work, and what is the after working, what is the results we are expecting from the intelligent machines. That all is called sequentially executing the planning, that all written in the programs and kept in the intelligent machines. That is one of the concept of main goal of AI. Planning is very important. Next, learning. How to learn the things or data from the old data, fact data, and how to make the machines to smart. That is what learning. That is the change actions from the old data. With the process of mathematical models, data to help the computer to learn without direct instructions. Mathematicals with the help of mathematical, without the direct instructions, how to process, we have to make a, to help a computer to work, learning all those things. And out of that, new facts are learning from old data. For example, image processing, retina. For example, retina, the whole retina, the image processing, and millions of data. How to learn the machines and how to take the image from the new diseases on retinopathy. How to generate that new concept after learning that image processing, how to make that where the actual nerve damage occurs, fundas. That is what called new concepts. And how to make a distinguish the situations and environments, and where to how to make a different situation. What is situation is there? What you are doing that one, and how to make a new environment that from the machines, intelligent machines. That is also learning in the machines. For example, let me take that one. An algorithm will be trained with the pictures of dogs, other things labeled by humans. The machine would learn ways to identify a picture of ducks on its own. The picture of ducks, we can label it of many ducks. That machine or that system, we can learn by identifying the dogs by the label. What kind of label it is there, it understand it and accurately understand what kind of dog, so its specification, where it comes from, what type of its dog, what kind of dog it is. So that we can identify by its label that you can train the machines so that it can identify very easily, fastly when compared to humans identifications. The machines are identifying so that human power is not necessary. A n number of dogs we can take it by labeling the dogs. Labeling means what are the specification of labeling. We can identify this. These kind of dogs are there, kinds of dogs by the machines, trained machines. Not a trained machines means whole data we are training, which algorithm also we are giving. Based on algorithms, it's going to train a decision making and learning, planning that we can disease the dogs. Interacting with the environment. What type of interacting with the environment means? The perceptions, actions are going to the memories and beliefs. In order to intelligent behavior, we are interact with the environment. How to make it that perceptions, actions interact with the environment means based on memories and beliefs, so that intelligent behavior interact with the our environment. So what is this interacting with the environment based on old memory belief means accessory sensory input, vision, sound interact with the humans, and what kind of language is speaking, text, speech, graphics, and all these things present interacting with the environments. These are all the learning things, planning, recognition of speech, text, all those things are there in the graphics so that we can interact with those all environments. So these are all the things we are going to the for particular systems or machines. We are making the machines to very strong, as we see the number of inputs, decision making, and learning frames and scripts and programming, knowledge decisions, specific domains, all those things. What kind of data we are training, speech, languages, text, image, and graphics, everything has kept made programming to the machine, intelligent machines. Finally, it gives us acting even they replace intelligent machines rather than humans. So coming to the overall, what is this advantages of artificial intelligence? That it's a more powerful, useful computers, and new and improved interfaces. Interfaces are very necessary to do it for the robotics, machines, and surgery for in healthcare and surgery operations, and many more things are needed. Rovers, all these things are needed. Improved interfaces, reduction in human error, takes a risk instead of humans, solving the new problems, better handling of informations, better handling the what information we are trained the systems, machines, it is better handled, and release the overload informations. The machine can release that overload information. That also it understand when to relieve this. So when to take the overload, that machines will take care of those things. Conversion of information into knowledge. What the information you are giving to updating that machines, how it converts into a knowledge to work a specific domain and knowledges. What are the drawbacks of this AI? Basically, it costs because costs are more because of hardware is dominating here, more hardware dominating because hardware and software are both there because hardware cost is increasing. Difficulty with the software development because some methods in AI, machine learning or deep learning. So software's development as a requirement is very expensive sometimes, maybe slow. So it's difficult to me updating that one and also may not be the correct solutions for specific domains, specific task also. And few experienced program also because of this slow and fast developers cannot think out of this box. Once we given a specific task, you cannot think out of the box, a particular domains. That is one of the drawback. A few practical products have reached the market, still not yet reached the market. Just to reach to market this AI products to right now. That is one of the drawbacks. The increasing dependency on machines. We are all people, we are humans depending upon machines. Every machines in our daily life, depending upon machines. For example, in our daily life, simple example, washing machine. They are also made by this AI, best washing machines. That is also depending upon the machines. And social ills. Social, it causes a social ills, unemployment, end of humanity, all those things. That is one of the major drawbacks of this the AI. The periods, if you come to periods of it from the John McCarthy periods to the early period, there were there in the game playing and theorem proving, biological models are there. In early modeling, it's the early expert knowledge, use of knowledge. Next, if you come to 80s, the booming this knowledge, rule-based system, knowledge-based representation systems. In periods in 90s, new millennium in artificial intelligence, in real-world applications like modeling, use of theory, and using neural network, fuzzy logic, and autonomous systems, in automation systems, in automobile industries, data mining. All these things are came into the 90s. This come to this is the road path of the artificial intelligence. Many applications are there. You cannot countless because visual recognition, traffic, medical diagnosis, directory inquiries, power plant control, automatic cars. In every automobile industries now they are implementing this kind of artificial intelligences, healthcare systems, so many things, so many applications in the world. Especially in the take particular applications like autonomous rovers. Rover is moving. So based on this AI applications, this rover is moving. When it comes to obstacles, so how to move, how to move when it comes to the in front of the obstacle, that take left or right. That is a decision making. This a vehicle, a robotic vehicle, space exploration vehicles. That is autonomous rovers is one of the best applications in the AI. Military robots, the robots are making that one is making the animals picture like robots faster and more accurate than the animals, and decisions, knowledge representation, how to based on the information kept inside these programs. The military robots also works. This humanoid robots also works, walk, turn, stairs, and telescope of making this the data and view of images of scenes, analysis of data, especially particularly in many image processing. The number of data we are going to take by using machine learning, because machine learning handling complex data, even the machine learning is unable to handle the complex data. If you go to deep learning, it solves the deep learning complex problems, n number of data handling. So as we see in the analysis of data, you can see these data. These are pictures data. And if you see this medicine, brain surgery, and how to take this surgery images, and particularly in the knowledge-based representation system, human cannot make, even surgery also can done it, and image photos also we can make it, and image analysis of enhancement of a nameplate, and many more things are we can do in nowadays. Autonomous vehicle control, as you see the what kind of vehicle control is there, you can read by AI machine. Pedestrian detection in transportation. Either man is passing through a camera, so which man, what kind of man, what is his color, and what is wearing dresses, the male or female, like that we can analyze complete data, the information kept inside the cameras, we can analyze this using AI machines. Games, as you see already, that in games, chess and Sukuro and robotics, small kind of kids playing, like all these things. Other AI applications also there: bioinformatics, text classification, documents, video image classifications, musics, especially natural language processing. As we done already, actually I will show tomorrow. I think uh, our industry experts take this FDP. They are very particular about AI and image processing. In between, time permits me that I will take you that how Retina will goes through it one using artificial intelligence in Retina, how it works when you take a subset of ML and DL, machine learning and deep learning, that how it works. The one by one, that how Retina will, we are going to taking the image and next it is going to that.
29ರಿಂದ 2 ಹೊತ್ತು ಎಷ್ಟು ಸಾಗತ್ತೆ ಇವ್ರೇನು ಹಾಕಿದಾರಲ್ಲ ರಮಣ?
And we go through that one. If you that one in Retina AI intelligence, I will show you that in the tomorrow in between the time of sessions how it works. Retina artificial intelligence Retina for the complete details. If you see this figure 1, and more diagnostic compared to electrodiagnosis, genetic diagnosis, clinic laboratory, mass screening, and others. The diagnostic imaging is more in AI artificial intelligence. In artificial intelligence Retina, the deep learning takes the complex data because the more number of image processing is happening in the retinopathy, especially in diabetes mellitus, rather than the classic machine learning. The performance of deep learning is very higher than the machine learning, because it takes more number of data. Using the data, it gives accurate result, fast results. It helps to in the healthcare systems. That I will give the tomorrow if time permits me. I will show the run the program and how it efficiently works, especially in diabetes mellitus on retinopathy. And this is the actually I shown only in my work the only final figure of retinopathy. We can see the nerve damage in the fundas in the left side of this eye. So this is how this millions of data in the image are taken and finally found that this is a nerve damage systems, the vascular bundle centers, that we how we are done using a deep learning system from the subset of machine learning systems. That I will run you tomorrow. So that I will give tomorrow permits me that one. Thank you. Thank you for listening the patiently, all the participants. So if any notes is there, you can send to the chat box. Thank you.
Dear participants, the feedback link will be shared in the chat box soon and as well as in the WhatsApp group as well.